Hi everyone, as mentioned we're studying tectonic plates, and at the boundaries of the tectonic plates is where most of the action happens. It's where things are created and destroyed. So we've already drawn our mid-ocean ridge, which is where we are in sea spreading, which is to create our, our new crust. So if you're coming, that can't happen. So cross subduction.
So first we'll draw a continent on the side. Continents are relatively thick and less dense than seafloor. So this is going to be a mountain, this is going to be a volcano. So we're going to turn like this, and we're going to make this fairly thick. We're going to leave a little space there, and then we're going to draw over this. Now the continent, so we'll label this continent. Continent. Alright, continental plate, alright? So that is continental plate. And we're going to draw over here, this is going to be the subduction itself. And we'll put ocean on here. And right here, we're going to label this. You'll notice it creates a little dip here. That is a trench, a deep sea trench. Now, this is a very dense plate, so we're going to label this dense. We're just going to put dense here to remind us of that. It's very dense. The seafloor is very dense. Ocean crust is more dense than continental. So now the subduction itself is right here. This is subduction. Subduction is moving down. We'll label that up here, subduction. Alright. So, when the plate is sinking down into the mantle, we'll label this mantle, it's getting very hot. Right. And speaking of hot, one of the things that's driving this is that convection. So we'll draw the convection like this. Here's your convection, we'll label that. And when it sinks down, it's getting hotter and hotter. Two things are in the motion, the fact that it's more and the action. Remember, this is the rate you go, so it's a very slow process. When it goes into the mantle, it gets very hot, and eventually it melts. Most of it goes back into the mantle. Some of it will rise, because remember, hot things rise. So it's going to rise, it's going to work its way through the cracks in the earth and the continent, and it's going to eventually, there's a little volcano, it's going to cause it, there's a magma chamber. We're going to create the ring of fire explosive volcanoes here. So that causes the explosive volcanoes. These are the ones that explode. Very dangerous. And while volcanoes create things, they destroy things, they also create. We'll talk about that later. So, we've seen that it creates a trench, a deep sea trench. It creates a volcano. The other thing that's created are earthquakes. So as the plate sinks, it's rubbing against the other plate, and that action creates earthquakes. Nothing can stop this motion. It's the strongest thing in the world. Nothing can stop this plate from moving. So it will slam into that continent. There'll be boulders in its way, but it's going to move its way through. And when it cracks those boulders and releases the energy, you get an earthquake. The more shallow the earthquake, the more dangerous it is. Now, these earthquakes can also cause tsunamis. That's very rare compared to the other things we're seeing here, but an earthquake here can create a tsunami. So that's just something else that happens near the ring of fire. A more advanced topic that I'll mention now is one of the evidences for this happening is not only mapping the earthquakes as they go down and seeing uplifting here, but the fact that scientists can detect carbon-12 coming out of the volcano. Let's talk about that for a minute. So when seashells and other small sea life, even some of it's very small, they build their skeletons and structures out of calcium carbonate. And
that has carbon in it. It has a special kind of carbon. We call it carbon-12. So when the seashells and microscopic life dies, it sinks to the bottom of the ocean, and it turns into carbon-12. So you get it accumulating at the bottom of the ocean. And that sea life and those shells all get dragged down in with the subducting plate. Now by the time they get to about here, they are no longer intact. They're being basically super crushed by extreme pressure and heat. You get extreme pressure and heat, so you get metamorphic rock. We're going to talk about that in the rock cycle, but the extreme heat and pressure will literally destroy those fossils at this point. However, the atoms are not destroyed. You cannot destroy matter, you just change its form. So we're going to have carbon-12 atoms being pulled down into the mantle. Now some of that carbon-12 is going to rise up, and it's going to blast out of the volcano. So the carbon-12 that's here, which is a unique kind of carbon, carbon-13 is what we have most abundantly in the air. But this carbon-12, which comes from these seashells, is further proof that the sea floor is subducting. The fact that you have carbon-12 exploding out of volcanoes, showing that subduction is happening and the sea floor is subducting under the volcanoes. Part of why they're explosive is, number one, they have very thick lava, which is like a cork magma. Secondly, it's because there's gases from the ocean getting trapped in here, and that forms like steam and it explodes. So these are very explosive volcanoes. So I hope that helped and everyone was able to follow along and draw this with me. And that is subduction. I'll mention one more thing about this. The seafloor spreading created crust. Down here it's destroying crust. So we're going to say this is destructive. It destroys crust. So we create it with our seafloor spreading, and then we destroy the crust in subduction. And subduction is a convergent. It is convergent, right? Because we're converging plates here. You might say it's also transform, where it's sliding side by side here. But overall, it's a very destructive force, and we have to have that because we're creating lithosphere at the mid-ocean ridge. We can label this sea floor here too, just to make that real clear. Sea floor, which is lithosphere. Lithosphere. Here we go. All right. I hope that helped everyone, and have a great day. Thank you. Bye.